This is day 4 of our countdown to the AP exam, and today we're going to look at Taylor and Taylor series and error. Both of these questions one question came from the 2016 administration of the test and the other one came from the 2015. But you are guaranteed to have a Taylor question on the AP exam, and it's generally question number 6. All right, so what we need to know, you absolutely positively need to know these 4 functions. If you have not memorized these 4 functions, you need to do so now. There's just no getting around it. I know we talk about not memorizing things these days, but you have to memorize these 4, okay? The other thing that you have to do is you also need to know how to write a Taylor and a Maclaurin series. A Maclaurin series is just the Taylor series centered around 0. So it's not necessary to memorize both. You can just do this one and just remember if it's centered at 0, it's 0. Okay? Then also you need to know error. So remember M, this M is what's going to maximize the error, maximize the derivative on an interval. Generally, if we use in Lagrange, this is given to you in some form or another. Okay, so this is from the 2016 administration of the test. And what we're given is a formula for the derivative. We're also given f of 1 and f prime of 1, and they want us to write a Taylor series for that. Okay? So they want us to write a Taylor series, so that means that we have to use the formula that we talked about a second ago. So we're going to use, we're using this formula. So we have to find f of 1, f prime of 1, which they gave to us, and then find the next derivative. So let's start by what they gave us. So they gave us that f of 1 is equal to 1. And then f prime of 1 is equal to negative 1/2. And so now we need to find, they want us to write the first 4 non-zero terms, so we need to find the next 2 derivatives. So to find the second derivative at 1, I use the formula that they gave us. So negative 1, in this case, if I'm finding the second derivative, n is 2, and this would be 2 minus 1 factorial over 2 squared. And doing the math here, 2 minus 1 is 1, so it's no longer alternating, so it's going to be plus 1/4. That's my second derivative. My third derivative is going to be negative 1 to the third, 3 minus 1 factorial over 2 to the third. So my third derivative is, it's going to be negative. 3 minus 1 is 2, so 2 factorial over 8, so 1/4. Now to write my Taylor series, okay? So I start by writing f of 1 plus the first derivative times x minus 1 raised to the first power all over 1 factorial. Now, of course, we don't have to write that 1 factorial. I'm just doing it so you can see the pattern. Then the next derivative would be plus 1/4, because this is the second derivative, x minus 2 squared, and where'd 2 come from? I don't know either. X minus 1 squared over 2 factorial minus 1 over 4 x minus 1 cubed over 3 factorial. Now, I can simplify this, of course, but it's not necessary. You can write it just like this, but if you want to simplify it, it would be 1 minus 1/2 x minus 1 plus 1/8 x minus 1 squared minus, let's see, 3 factorial is 6, so 4 times 6 is 24, so that would be 1 over 24 x minus 1 cubed okay? They just wrote 2 cubed times 3, which is, in either case, is 24. Okay, so that would be our Taylor series. And now they want the nth term. So one of the things that we can do with the nth term, we can use the formula that they gave us, and this is the safe thing to do, is just use the formula for the derivative. because remember the nth term plus dot, 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 the nth term is going to be the derivative. So what's that derivative? That derivative is negative 1 to the nth, n minus 1 factorial over 2 to the n, and then the only thing that we're adding to that is n factorial. So technically, that is the nth term. Now, if we want to clean that up a little bit, so it'd be plus dot, dot, dot this, but we could also clean that up a little bit too and write it as negative 1 to the nth over 2 to the nth times n, if you want to clean it up. You really don't have to. Then the more simplifying you do, the greater chance of making a mistake. So where did the points come from on this question? So you got 1 point for the first 2 terms, which everyone should have gotten the first 2 terms because that was given to you. You got 1 point for the third term. You got 1 point for the fourth term. Now let me just say that if they ask for 4 terms, do not give them any more than 4. And then you got 1 point for the general term. So with my students, if I ask for 4 terms and they give me 5, I subtract 1. If I ask for a third degree and they give me a fourth degree, I subtract 1. I subtract a point. Okay? Then they ask us to find the radius of convergence. No, I'm sorry, the interval of convergence if the radius of convergence is 2. Well, if the radius of convergence is 2, then we know that x minus the center has to be less than 2. So that gives us negative 2 is less than x minus 1 is less than 2. Adding 1 to everything gives us negative 1 is less than x is less than 3. So you got 1 point for that answer. But however, you remember you have to check your endpoints. And when you check your endpoints, one of the things I'm reading is that their complaint is that students' work is unorganized and not labeled. So if I were you, I would write check endpoints. I would label my work as check endpoints and show that I was checking the endpoints. So as I check at x equals negative 1. So we are putting that into the nth term. So the nth term is written on the other page, but I'm just going to write it here. It's negative 1 to the nth, 2 to the nth times n times x minus 1 to the nth power. Okay? So when we check our endpoints, we're inputting this negative 1 in for x. So that gives us negative 1 to the nth times negative 1 minus 1 to the nth, 2 to the nth times n. Okay? Doing the math here, what we find is that this becomes negative 1 to the nth times negative 2 to the nth over 2 to the nth. Now, because this is a negative and this is a negative, this is no longer alternating. And I can multiply these two together because they have the same exponent. I can multiply the numbers together and I get 2 to the n over 2 to the n over n. Well, that cancels, and now I have 1 over n, which is no longer alternating, so it does not converge. So this diverges, and it diverges by p-series or harmonic series. Now, whether or not you have to tell which test you use, I don't know, but be as specific as you can here. And then we want to say, okay, now we're checking the endpoint at x equals 3. So that's negative 1 and negative 3 minus 1 to the nth over 2 to the nth n. Oh, that's positive 3. It's not negative 3. Sorry, that's positive 3. So that gives me, and that's to the nth power. So that's negative 1 to the nth over times 2 to the nth, 2 to the nth over n. Well, now these two cancel, but this becomes an alternating series. So now I have negative 1 to the nth over n. And this converges by the alternating series test. Because it's alternating, the terms are decreasing, so I can say it converges by the alternating series test. So therefore, my answer would be -1 is less than x is less than or equal to 3, and that was worth 1 point. But you only got this point if you showed work. So make sure you show your endpoints and label it. C is pretty straightforward. All we're doing is we're taking the first 3 terms that we developed and approximating 1.2. So that is simply the approximation of 1.2 is 1 minus a half times 0.2, or 1, it's 1.2 minus 1, which is 0.2, plus 1/8 0.2 squared. And I don't think you have to simplify that any further, but if you did simplify it, you would get that that is 0.905. Sorry, my pen had to catch up with me. And that was only worth 1 point. The last one is show that the approximation found in Part C is within 0.001. So since in Part C we used the second derivative, we use the third term, our next error has to be less than the 4th term. So we have to show that the actual, the absolute value of the actual minus the approximation has to be less than 1 over 1,000. Okay? So we're going to use the next term to prove that. So the next term was negative, so the next term is -1 over, what do we say, 24? X minus 1 to the 3rd power. That's the next term. So to show that it's less than this, I have to evaluate this term at 1.2. So this is -1 over 24. 1.2 minus 1 cubed has to be less than 1 over 1,000. And what we get, and I'm not sure how much of this you have to write, but what we get is 1 over 3,000 is less than 1 over 1,000. Okay? And so this was worth 2 points. You got 1 point for showing that you used the alternating series test, and you had 1 point for the evaluation. So what disturbed me about this question is the mean score was 3.82, but 23% of the students did not even earn any points on this problem, and that's a little disturbing. I think you should be able to do at least, to have gotten some points on that. Basically, I think it was pretty straightforward, and you should be able to do it. You should have gotten at least 4 points on that question. Above the average is where it's our aim. Our aim is to do the best we can, but above the average will get us a 5. Okay, so this is from the 2015 administration of that, and once again they want us to start off by using the ratio test. This time they give us the nth term, and they want us to use the ratio test to find the radius of convergence. Now notice they only want the radius of convergence, so don't go through and do the whole interval of convergence, checking endpoints. That's too much. They just want the radius of convergence. So that's going to be the limit as n approaches infinity of -3 to the n minus 1 plus 1 x to the n plus 1 over n plus 1, and then we flip it. So n goes on the top, and then x to the n on the bottom, and -3 to the n minus 1. Okay? So when we simplify this, the -3 to the n, this zeroes out with that, and so we're just left with, notation is important, so make sure you write the limit and you write the absolute value. So this cancels with that, and we're left with 3 to the first power. This x to the n cancels with that, and we're left with x. And then the n's, as we go towards infinity, the n's cancel. So I'm left with absolute value of 3x. And we know this has to be less than 1. So to find the radius of convergence, I have to get the x by itself. So this will give me the absolute value of x is less than 1/3. So the radius of convergence is simply 1/3. So that's the answer. So where did your points come from? 1 point for setting it up, 1 point for your evaluation, and 1 point for the answer. Okay, now this is an interesting one because a lot of students miss this because of this last part. Express it as a rational function. Although most of you, hopefully everyone can do this part. So don't allow, remember, do what you can. If it's something you truly don't understand, that's okay, but do the part that you can. So hopefully most of you could get the first 4 non-zero terms of f prime. So to do that, the first thing we have to do is get the first 4 terms of f of x. And they gave us 3 of them, if I remember correctly. They gave us 3 of them. So they gave us x minus 3/2 x squared plus 3x cubed. And then we were tasked with finding the 4th one. And to find that 4th one, we know the general term. So we know this general term. So to find the 4th term, we do -3, 4 minus 1 over 4, x to the 4th, which is going to give us -3 cubed over 4, x to the 4th. So my 4th term is -27 over 4, x to the 4th. That's my 4th term. So, but you got no points for that. You got points for finding the derivative. And to find that derivative, it's just take the derivative of each of these individually. So 1 minus 3x plus 9x squared minus 27x cubed. So that was worth 2 points. Now, how do we find, they want us to write it as a rational function. Anytime they say write it as a rational function or a geometric, those are the 2 things you need to look for, to say rational or geometric. We have to look to see what am I multiplying by each time. And what I'm multiplying by each time is 3x. So my r is 3x. This is the r in the geometric. So to find the sum of this, it would be a, so the initial term is 1, and then 1 minus, I'm sorry, that's -3x, 1 minus -3x. So the sum of this can be written as 1 over 1 plus 3x. So f prime of x can be written as 1 over 1 plus 3x, and that was worth 1 point. So it was worth a total of 3 points. Notice the most of those points came from being able to take the derivative, which we all should be able to do. All right, and C, the first thing it asks us to do is to write the first non-zero terms for e to the x. So as I said in the beginning, you should know e to the x. Now, if you have the time on the test and you don't remember it, you can do a Taylor for it and find all the derivatives, because e to the x is easy. But it's so much easier when you can just write those terms. So 1 plus x, see how much time this takes compared to having to sit there and figure it out. 2 factorial plus x cubed over 3 factorial, and that was worth 1 point, and every point counts. Every point is important, okay? Then they want us to multiply that times f of x. Now, the thing is to remember, we just have to remember our algebra skills. And that was x minus 3/2 x squared plus 3x cubed. Now that looks daunting, right? But the key is they tell you only have to go to the third derivative. So anytime when you're multiplying, anytime you get something greater than the third derivative, you can stop. dot, dot, dot. I'm just saying it continues. Okay. So as I multiply this, I'm going to go back and use FOIL. I guess I'm not exactly using FOIL, but I'm going to multiply 1 times x, and that's x, and then x times negative 3 halves x, so that's negative 3 halves x. No, I'm sorry. Then I should multiply. Okay, how do you multiply again? Maybe I don't remember. Let's get rid of that one. So then I multiply 1 times x, and then 1 times negative 3 halves x gives me negative 3 halves x squared, and then 1 times 3x cubed. Then I'm going to multiply I need another color. I need something a little darker than this. Let's try this blue. So the next thing I'm going to do is I'm going to multiply x by each of these. So x times x is x squared, and then x times negative 3 halves x squared is negative 3 halves x cubed. So since I have x cubed, there's no need to multiply by this one because that would give me too much. That would be, the power would be too great. So then I would do the next one, which is x squared over 2 factorial, and that would be plus, this is a mess, x cubed over 2 factorial, and if I try to go again, it would be too high. And I can't multiply this by anything. Did I do? Yeah, I did that one, and I can't go again because it would be too high. And I can't multiply this by anything because it would give me something greater than x cubed. So this is the answer that they were looking for. And if you simplify this, and remember, so this is x, and then I can pull out an x squared and have negative 3 halves plus 1. And then I can pull out an x cubed and have 3 minus 3 halves plus 1 half. And when you simplify that, you get x, let's see, negative 3 halves plus a half is negative 1 half. And 3 halves, negative 3 halves plus 1 half is negative 2 halves. So that's negative 1, so that's plus 2x cubed. Yep, and that's the correct answer. All right, you don't have to simplify, but it wasn't that bad. Okay? Now, I want you to notice some of the things they said about this. 3.96 was your average. Approximately 9% of the students didn't earn any points on this problem. It's difficult to follow student solutions, and there were many presentation and notation errors. So you want to be very neat and organized in your work and label everything. You also want to make sure you're using the correct notation. In Part B, most students were not able to find the sum of the geometric. You know how to do that now, so you should be able to do it. But this is what got me. Some students simply did not know to many students earned the first point. Some students did not know the Maclaurin series expansion for e to the x. That better not be any of my students. You all should know e to the x, cosine x, sine x, and 1 over 1 minus x. And then a lot of kids just didn't think about using just basic algebra to multiply those series together. Okay? All righty, that's it for that. And you're gonna do amazing on the AP exam. You're gonna make a level 5. You're gonna do such an amazing job.